Right, so I wanted to just give you this question for homework, but I just want to do a little bit of info on it, I suppose. So the question that we did for homework last night was where we had the area bound by a curve and like the x-axis or the y-axis. Sometimes you can get like the area bound between two graphs. Like in this case, it's between a curve and a line. All right, so same as the previous one, you need to be able to sketch it pretty accurately. I mean, you can sketch it badly. It's not about the sketch, but I just find that it's easier to get the answers right if you sketch it more accurately. So sorry, I'm trying to type this in. X squared minus 2x plus 2 equals that. Tiny area enclosed between, I don't know, we'll do 1:5 and see what happens. Okay, so I have 1, 1, 2, 2, 3, 5, 4, 10. Let's go to 17, 5, 17. Okay, so this is the curve. The line then is quite straightforward. Y equals x, so whatever the x value is, that's what the y value is. So it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Now, I might need to extend that. I'm not 100% sure. So we'll sketch what we have and then decide if we need to extend it further. Okay. Shapes, graph. Okay. So my x-axis only needs to go to 5. So 1, 2, 3, 4, 5. It's my x-axis. 1, 2, 3, 4, 5. My y-axis needs to go to, was it 17? So 2, 4, 6, 8, 10, 12, 14. Right, that's 16. I'll be able to gauge it from there. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so in green, we'll do the curve. So the curve is 1, 1, which is there. 2, 2 is there. 3, 5 is there. 4, 10 is there. And then 5, 17. So that's 16, so that's 17. What would 0 be? If I were to sub 0 in, I would get 0 squared minus 2 times 0 plus 2. So I get y equals 2. So that's actually gone back up. Okay. So if we try and do this. Yeah? So that's that. And then the line is 1, 1, 2, 2. So the first 2 points are the same. And then it goes 3, 3. And then 4, 4. And then 5, 5. Yeah, kind of like that. So I'll try and drop a line here. So we go yellow, insert a line, and it would be 0, 0 as well, wouldn't it? If x is 0, y is 0, yeah. Okay, so we'll try and go through all of these. Did that happen? It's close enough. Oh. So the area, if I keep going in, bound by these two, is like that tiny bit there. So it's find the area enclosed between, yeah. So it's that tiny bit there. So the quadratic graph comes under and the linear graph goes over. Yeah? Right, so let me explain how you do this. So when you integrate, remember that you get the area under the curve. Okay? So if we integrate, I don't know what colour to do it in. Now we need to know where these graphs intersect, so that's another bit of maths we're going to have to do. But if we integrate under the line, so if you integrate under the line, you'll get, and I'll rub this off now, but you get like that bit, like all of that, right? And then if you integrate under the curve, so I'll try it in, can I make this really light, I wonder? Sorry, now, let me try and change the colour. I go, get really light, something like that. Let's try that. Okay, so if I integrate under the line, it's not light enough, but you get my idea, right? It's that bit under the line. And then if you integrate under the curve, you get this bit. And if you subtract them, that leaves you with that bit. Yeah? So you do the area under the line because that's the higher one. You minus the area under the curve because that's the lower one. And when you subtract them, that leaves you with the area bound, which is that little bit of black there between. Yeah? The only thing I'm missing is those limits. And the limits are basically left-hand side and right-hand side where they meet. So essentially what I'm looking for, and this happens a lot, I'm looking for where the graphs intersect. And if we're looking for points of intersection, the maths is simultaneous equations. So we are looking for the point of intersection of these two. Now it should be nice and straightforward. Essentially, they're both equal to y, so we can just do y equals y, which gives us x squared minus 2x plus 2 equals x. And then we can solve. So if I minus x, I get x squared minus 3x plus 2 equals 0. Side is 2, which is 2 times 1. I'm trying to get a minus 3, so minus 3. So x squared is I want you to finish that. And then we're just like, there's one thing left, but basically I'm going to put for tomorrow, we're just going to do a few area bound paper questions. And that's how we're going to practice this. Is that all right? So when you down questions, there's an awful lot of algebra. So simultaneous equations, obviously functions, sketching graphs. Always good to get a picture of what you're doing. You almost always need to get points of intersection. So there's a lot of simultaneous equations. And then at the very end, once you know what you're doing, the integration comes in. So hopefully, from an area point of view, you understand the integration. So it's always the area under the higher graph minus the area under the lower graph to give you the area bound. And then obviously you have to integrate, sub in your limits, and then you'll end up with whatever that little area is. Okay, so finish that off, please, along with the rest of question 8.